Installing service entrance cable connectors backward is a violation of the National Electrical Code. The NEC mandates that connectors must be installed in the cable in the correct orientation. The design of set screws and locknuts is intended to establish a secure connection between the connector and the cable. When the connector is installed backward, the set screws and locknut cannot properly engage with the cable, potentially resulting in a loose connection. A loose connection introduces several problems. Firstly, arcing. Arcing is a dangerous electrical discharge that occurs when electricity jumps across a gap between two conductors. This can generate intense heat and can ignite nearby flammable materials. Secondly, overheating. Overheating results from increased resistance in the loose connection, causing excessive heat buildup. This heat can damage the insulation of the wires, potentially leading to a short circuit or fire. Thirdly, fire. A loose connection significantly increases the risk of fire due to the combination of arcing and overheating. The excessive heat can ignite nearby materials, leading to a potentially devastating fire. Beyond these immediate hazards, a loose connection can also lead to a loss of power or a malfunction of electrical equipment. Intermittent power outages can disrupt essential services and damage sensitive electronic devices. Furthermore, the equipment connected to the circuit may malfunction due to the unstable electrical supply. To prevent these issues, always install the connector on the cable in the correct orientation. Adhering to this practice ensures a safe and reliable electrical connection. This explanation aligns with the 2014 NEC. To further clarify, consider the specific requirements outlined in the NEC related to cable connectors and terminations. The code addresses proper installation methods to ensure the integrity of electrical connections. Ignoring these requirements can lead to serious consequences, emphasizing the importance of following the NEC guidelines. When installing service entrance cable, it is important to select the appropriate connector for the cable size and type. Using the wrong connector can also result in a loose connection, even if the connector is installed correctly. Refer to manufacturer specifications and NEC tables to ensure proper connector selection. It is also crucial to properly tighten the set screws and locknuts on the connector. Over-tightening can damage the cable or connector, while under-tightening can result in a loose connection. Use a torque wrench to ensure that the set screws and locknuts are tightened to the manufacturer's specified torque. Furthermore, it is essential to inspect the connection after installation to ensure that it is secure. Check for any signs of looseness or damage, and retighten the connections as needed. Regular inspections can help identify and address potential problems before they escalate into more serious hazards. In addition to the installation of the connector, the proper support and securing of the service entrance cable are also important. The NEC specifies requirements for supporting cables to prevent strain on the connections. Cables that are not properly supported can sag or pull on the connectors, leading to loose connections over time. Therefore, ensure that the cable is adequately supported according to the NEC guidelines. When working with electrical systems, it is always important to prioritize safety. Always de-energize the circuit before working on any electrical connections. Use appropriate personal protective equipment, such as gloves and eye protection, to prevent electrical shock or injury. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Moreover, it is crucial to stay informed about the latest updates and revisions to the NEC. Electrical codes are constantly evolving to reflect new technologies and safety standards. Staying up to date with the latest codes ensures that your electrical work is compliant and safe. Consider attending training courses or consulting with experienced electricians to enhance your knowledge of electrical codes and best practices. Also consider additional factors that could contribute to loose connections, such as corrosion and vibration. Corrosion can occur over time, especially in damp or corrosive environments, which weakens the connection and increases resistance. Vibration can also loosen connections, particularly in areas with heavy machinery or traffic. To mitigate these risks, use corrosion-resistant connectors and secure the connections properly to minimize vibration. Regular inspections can help identify and address any signs of corrosion or loosening. In summary, installing service entrance cable connectors backward is a clear violation of the National Electrical Code due to the potential for loose connections and associated hazards. Adhering to proper installation techniques, selecting the correct connectors, tightening connections to the specified torque, and regularly inspecting the connections are crucial steps to ensure a safe and reliable electrical system. Always prioritize safety and consult with qualified professionals if you have any doubts or concerns. Remember that electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from harm. To add more detail, let us consider the consequences of ignoring NEC guidelines more closely. Failing to follow the NEC not only poses safety risks but can also lead to legal and financial repercussions. Electrical installations that do not comply with the NEC may be subject to fines, penalties, and even legal action. Insurance companies may also deny coverage for damages caused by non-compliant electrical work. Therefore, it is imperative to adhere to the NEC to protect yourself from liability and financial losses. Another aspect to consider is the impact of environmental factors on electrical connections. Temperature fluctuations can cause expansion and contraction of materials, which can loosen connections over time. Extreme heat can also degrade the insulation of wires and connectors, leading to increased resistance and potential failures. To address these challenges, use connectors and cables that are rated for the specific environmental conditions. Proper ventilation and insulation can also help mitigate the effects of temperature fluctuations. Furthermore, consider the importance of proper grounding and bonding in electrical systems. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. Improper grounding and bonding can increase the risk of electrical shock and equipment damage. Therefore, ensure that all electrical systems are properly grounded and bonded according to the NEC requirements. Let us delve into the details of selecting the right type of service entrance cable. Service entrance cable is available in various types, including SE, US, and SIR. IC cable is typically used for above-ground installations, while US cable is designed for underground installations. SER cable is a type of SE cable with a reduced-size neutral conductor. Selecting the appropriate type of cable depends on the specific application and local codes. Always consult with a qualified electrician to determine the correct type of cable for your project. In addition, consider the ampacity of the service entrance cable. The ampacity of a cable is the maximum amount of current that it can safely carry. The ampacity of the cable must be sufficient to handle the load of the electrical system. Refer to NEC tables to determine the appropriate ampacity for your application. It is always better to oversize the cable slightly to provide a safety margin. In addition to connectors, consider the importance of using the right tools for electrical work. Using the wrong tools can damage the wires or connectors, leading to loose connections. Invest in quality tools that are specifically designed for electrical work. These tools will help you make safe and reliable connections. When making connections, always strip the insulation from the wires carefully to avoid damaging the conductors. Use a wire stripper that is designed for the size of the wire. Avoid using knives or other sharp objects, as these can nick the conductors and weaken the connection. After stripping the insulation, clean the conductors to remove any dirt or debris. This will ensure a good electrical contact. Use a wire brush or a clean cloth to clean the conductors. Furthermore, consider the use of antioxidant compounds on aluminum conductors. Aluminum conductors can oxidize over time, which increases resistance and can lead to loose connections. Applying an antioxidant compound to the conductors before making the connection can help prevent oxidation and ensure a reliable connection. When tightening the set screws and locknuts on the connector, use a torque wrench to ensure that they are tightened to the manufacturer's specified torque. Over-tightening can damage the cable or connector, while under-tightening can result in a loose connection. Refer to the manufacturer's instructions for the correct torque specifications. After tightening the connections, inspect them carefully to ensure that they are secure. Check for any signs of looseness or damage. If you find any problems, retighten the connections or replace the connector as needed. In addition to visual inspections, consider using thermal imaging to detect hotspots in electrical connections. Thermal imaging can identify areas of excessive heat, which can indicate a loose connection or other problem. Regular thermal imaging inspections can help identify and address potential problems before they escalate into more serious hazards. Let us also discuss the importance of proper labeling of electrical circuits. Labeling circuits clearly and accurately makes it easier to identify and troubleshoot problems. Use a permanent marker or label maker to label the circuit breakers and wiring. Include information such as the circuit number, the area served, and the load connected to the circuit. Clear labeling can save time and effort when troubleshooting electrical problems. Always document any changes or modifications to the electrical system. Keep a record of all wiring changes, circuit additions, and equipment upgrades. This documentation can be valuable for future troubleshooting and maintenance. Store the documentation in a safe and accessible location. Remember, electrical safety is an ongoing process. It requires constant vigilance and attention to detail. By following the NEC guidelines and best practices, you can ensure a safe and reliable electrical system. Always prioritize safety and consult with qualified professionals if you have any doubts or concerns. Electrical codes are continuously being revised and updated. Familiarize yourself with any local amendments or interpretations of the NEC to ensure compliance. Stay informed about new technologies and best practices in the electrical industry. Continuous learning is essential for maintaining a safe and efficient electrical system. Finally, promote electrical safety awareness in your community. Educate others about the dangers of electricity and the importance of following safety precautions. Share your knowledge and experience with others to help prevent electrical accidents. Electrical safety is a shared responsibility. By working together, we can create a safer environment for everyone.